In the Stephen reduction, we will use the stannous chloride in presence of HCl. There is a breaking of one bond will take place. As a result of this, imine products are formed, which is a imine hydrochloride. Always remember in the Clemmensen reduction, the carbonyl groups of an aldehyde, carbonyl groups of an aldehyde or a ketone, which get reduced to CH2 group. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, today we are going to start with the revision class for the Unit 12, Aldehyde Ketones and Carboxylic Acids. Okay, so in this unit, we are going to discuss with more about aldehydes, ketones and carboxylic acids. We all know that aldehyde, ketones and carboxylic acids are widely spread in plants as well as with the animal kingdom. And they play a very important role in a biochemical process of life, and in this chapter, it includes a knowledge about carbonyl group, that is a compound which are containing carbonyl group as their functional group. So what is a carbonyl group? How do we represent a carbonyl group? You can show with this diagram. So in the aldehyde, ketone and carboxylic acid, we can see that carbonyl group will be act as a main functional group, that is C double bond O group. You can see that the carbonyl group which are mainly present in aldehyde, ketones and carboxylic acid. So once a carbonyl group is there in the aldehyde, ketone and carboxylic acid, if this carbonyl group, if it is bonded with a hydrogen along with one alkyl group, then we said to be aldehyde. Suppose if this carbonyl group, if it is bonded to two same alkyl group, we say it is ketone. Suppose if the carbonyl group bonded to one alkyl group and bonded to a OH group, then it is said to be carboxylic acid. This is how the carbonyl group which are majorly present in aldehyde, ketones and carboxylic acid. In this chapter, we study the aldehyde, ketones and carboxylic acid and their derivatives. In aldehydes, carbonyl groups are attached to the two hydrogen atom. This R can also be an hydrogen, or one R with one aryl group also and one hydrogen atom. In ketone, carbonyl groups are attached to two alkyl or the two aryl group. So these two R and R may be alkyl groups or the aryl group, or it may be a same alkyl group or it may be a different alkyl group also. Whereas in the carboxylic acid, we can find only one alkyl group and also one OH groups are attached. From this unit, we can expect 9 marks. Remember, we can expect 2 5-mark question and there is a 1 mark question. Coming into the list of 1 and 2 mark and a 3 mark question. So in the 1 mark, we can expect the reagent based on question or the catalyst based on question also, and sometime any of the compounds can be given to name it also. Since it is very easy on naming process, they would have skip and they can ask with any of the reagent that we used in aldehyde, ketones and carboxylic acid. Meanwhile, we have studied in the laboratory also. Okay, name the reagent which are used in Stephen reduction. So in the Stephen reduction, we will use the stannous chloride in presence of HCl. So the stannous chloride with the presence of concentrated HCl, we used in Stephen reduction. Next, what is Tollens reagent? We all know that Tollens reagent is nothing but ammonical silver nitrate solution, which we call it as what? A Tollens reagent, and it is denoted as AgNO3. Okay. Next, what is Fehling solution? Fehling solution is a mixture of alkaline copper sulfate solution and sodium potassium tartrate. So it is sodium potassium tartrate solution. Now we will discuss a 1 mark question, 2 mark question and a 3 mark question in this unit. So in this unit, as I said, we can expect the question mainly from the reagent part. That is, they can ask with any of the reagent that we used in chemical properties of the aldehydes, ketones or the carboxylic acid, or during the preparation of aldehydes, ketones and carboxylic acid, which are the reagent that we have used, that can be asked for 1 mark. And sometime, they can ask you to give any of the compound to name it according to the IUPAC nomenclature. And most of the times, the question can be also raised from the chemical properties. Okay, few chemical properties that we have studied with the special features that can also be asked from this unit. We will see which are the 1 mark question which has been asked separately from this unit. The first question goes like this. Name the reagent which are used in Stephan reduction. In Stephan reduction, we will use a mixture of a stannous chloride with concentrated HCl. Okay, so the mixture of stannous chloride with the concentrated HCl will be used in Stephan reduction for the reduction of aldehydes. Okay, next, what is Tollens reagent? We all know that Tollens reagent, it is nothing but ammonical silver nitrate solution, which we call it as what? Tollens reagent. Okay, next, what is Fehling solution? Fehling solution is a mixture of alkaline copper sulfate solution with sodium potassium tartarate. Okay, it is an alkaline solution of copper sulfate with sodium or potassium tartarate. Potassium tartarate. Okay, next, what is formalin? We all know that 4% aqueous solution of formaldehyde, okay, which is an aldehyde, will be used to store for the specimen, which we call it as what? Formalin. Next, which type of the aldehyde will undergo Cannizzarose reaction? So, as we have already studied in the chemical property that Cannizzarose reactions will be usually observed when the aldehyde do not contains the alpha hydrogen atoms, will undergo Cannizzarose reaction. Which type of aldehydes will undergo aldol condensation reaction? So, usually the aldehyde which are containing alpha hydrogen atom, they'll undergo aldol condensation reaction. Okay. Remember, in a Cannizzarose reaction, even though the aldehyde do not containing alpha hydrogen atom, it can undergo Cannizzarose reaction. You will see the reaction in the 2 marks as well as in the 3 marks also. Again, I am going to explain it with an example. Whereas in case of aldol condensation, we must have a aldehydes with the alpha hydrogen atom. Then only, that aldol condensation will happen. Next, between the aldehydes and the ketone, which one is conformed by using Tollens reagent? We can conform aldehyde by using Tollens reagent. Next, between the aldehydes and the ketone, which one will be conformed by using Fehling solution? So, by using Fehling solution as well as the Tollens reagent, we can conform the aldehyde. Next, write the IUPAC name of the compound. So, here you can see that they have given the compound like this. We can see that both the side 3 times, we can see the aldehyde functional group will be there. So, you have to start numbering in this way: 1, 2, 3, 4, 5, 6. Remember, if it is an aldehyde, ketone or carboxylic acid, even though that carbon atom is having C double bond OH as a functional group, this carbon atom is also considered as a chain carbon atom while numbering or while naming also. So, how many carbon atom we have? 6. See that any substantive group is attached or not? No substantive groups are attached, so that naming will be goes like this. See, in this compound, how to name with the aldehyde? I'll go with the 1, 2, 3, okay, and 4 and 5. I know that to the third carbon atoms, the aldehyde groups are attached. Okay, so I can number from 1, 2, 3 and 4. Okay, or I can go in this order also: 1, 2 and 3. So, since if I go from left to right, it will get a least number. So, I'll go with the left to right, and this chain will be act like your side chain. Correct? So, how do you all number it? So there is no substituent group. So directly we are counting number of carbon atom. There are 3 carbon atoms are there in the chain. So it is prop afterwards. So where exactly you can, it is a propane. Why it is propane? There is no double bond or triple bond. So directly we can say it is propane. So which is your primary suffix is your alkane, and the secondary suffix is your functional group you have to see. So where exactly that functional groups attached? You can see that these functional groups are attached to the second and third carbon atom. Correct? So I can write 1, 2, 3 trichloroaldehyde. So how come it is 1, 2, 3? Because to the third carbon atoms, this aldehyde groups are attached. Hence, I can call this as 1, 2, 3 trichloroaldehyde or carbaldehyde. Next, we'll go with the 2 mark question now. Explain Glitterman-Koch reaction in the preparation of aldehyde. So, we all know that Glitterman-Koch reaction is the preparation of an aldehyde by using benzene. Okay, so benzene and its derivatives are treated with carbon monoxide and hydrogen chloride in presence of anhydrous aluminum chloride with a trace amount of cuprous chloride. Benzaldehyde or substituted benzaldehydes are formed. This reaction is said to be what? Glitterman-Koch reaction. So we are taking the benzene and its derivatives of benzene, okay, which we are going to treat with a carbon monoxide and HCl in presence of anhydrous aluminum chloride and the cuprous chloride. We got a benzene with the aldehyde groups are substituted, and it is named as what? Benzaldehyde, and it is a preparation of aldehydes. Okay, next. Explain Stephen reduction with an example. The reduction of nitrile into an aldehyde by using acidified stannous chloride at a room temperature, which gives an aldehyde. In this reaction, what will happen? The first, imine hydrochlorides are formed, and which is upon further hydrolysis with the boiled water, which gives an aldehyde. This reaction, which we call it as what? Stephen reduction. So first we are taking a nitrile. You can see that nitrile, in the sense there must be a triple bond between the carbon and nitrogen, which should be attached to an alkyl group. Okay, so when a nitrile, when it is treated with the stannous chloride in presence of an HCl, so how does this generate H plus ions? You must know. So stannous chloride react with an HCl, it forms what? Stannous trichloride with a H plus. Okay, so since we wanted 2 H plus, we have to take a 2 H plus to happen for the entire reaction. So that is why I have written H plus. So what will happen when these hydrogens are attached to this carbon atoms? What will happen? There is a breaking of one bond will take place. As a result of this, imine products are formed, which is a imine hydrochloride, which is upon further hydrolysis with the water, what will happen? Your nitrogen, this NH4, this NH will be combines with the Cl and forms what? NH4Cl. That is, the salts are formed, and the CO, okay, with the R and C, with the reduction with that water, which gives rise to an aldehyde. You can take one more example, ethane nitrile upon treatment with the stannous chloride and concentrated HCl, which forms imine, that is acetaldehyde hydrochloride, which is upon hydrolysis with the water, which gives an acetaldehyde. Okay, next. Explain decarboxylation with an example. So decarboxylation will comes under the chemical properties of carboxylic acid. Remember how to do with this. Okay, decarboxylation in the sense the process of removal of carbon dioxide group from the carboxylic acids. So carboxylic acid will lose the carbon dioxide to form a hydrocarbon when the sodium salts are heated with soda lime, and the reaction is called as what? Decarboxylation. So in your first PUC also you have learned the same reaction. Remember, soda lime, it is nothing but a mixture of sodium hydroxide plus calcium oxide, which we call it as what? Soda lime. So how does we are going to write the sodium salts? We know that carboxylic group is nothing but COOH. Okay, so and it is always attached to the R, that is the alkyl group. If I replace this H with the sodium, then it becomes what? Sodium salts of carboxylic acid, and we can write this as RCOO-Na. So with what? Sodium hydroxide in presence of calcium oxide, and when you provide the heat, what does it happen? This COO-Na and NaO. Okay. So how many sodium we have? 2 sodium. Na2, you can say COO. So I can write COO3. Then what is remaining then? We have R and lastly we have a H. So it forms what? Hydrocarbon. Okay. So this is how we can easily eliminate the carbon dioxide groups which is there in the carboxylic acid. This process which we call it as what? Decarboxylation. Next. Explain a Rosemont reduction in the preparation of an aldehyde. Okay. So, it is a preparation of aldehyde once again. Remember, this process was discovered by Rosemont. Aldehydes are prepared from acid chloride by the reaction of hydrogen in presence of palladium as a catalyst supported by the barium sulfate, which we call it as what? Rosemont reduction. Remember, when we take acetyl chloride or acid chloride, you can say, when we add a hydrogen for this in presence of any of the catalyst, you can take a nickel, platinum or palladium, it should be supported with a barium sulfate. Now what will happen if you add a hydrogen to this carbon atom? Usually we have a 2 hydrogen, no? 1 H and 1 Cl will be combined to form a HCl. So what is remaining? Only 1 H will be remaining. It will be goes and attacks to this carbon atom and forms an aldehyde. It's very simple. Similarly, acetyl chloride upon addition of an hydrogen in presence of palladium supported with the barium sulfate, 1 Cl combines with 1 H and forms a HCl, and 1 H can attach to this carbon atom and forms a acetaldehyde. Next, explain Clemmensen reduction with an example. So, in the Clemmensen reduction, what will happen? The reduction of aldehydes of the ketone to corresponding hydrocarbon on treatment with zinc amalgam and a concentrated HCl, which we call it as what? Clemmensen reduction. So, always remember in the Clemmensen reduction, the carbonyl groups of an aldehyde, carbonyl groups of an aldehyde or a ketone, which get reduced to CH2 group. You can see that I have taken an example of ketone, which is upon reduction with the zinc amalgam in presence of concentrated HCl, what will happen? The C double bond O group will be entirely get reduced to CH2 group. Hence, this process which we call it as what? Reduction. Clemmensen reduction reaction. Similarly, if you take an aldehyde and if you treat with the zinc amalgam with the concentrated HCl, it forms a methane. Okay. Next, what is Cannizzarose reaction? Give an example. So, as I explained, aldehyde, even though it do not contain the alpha hydrogen atom, can undergo Cannizzarose reaction. So, aldehyde do not contain the alpha hydrogen atoms such as formaldehyde or benzaldehyde, can undergo mutual oxidation reduction with a concentrated alkali, and this reaction which we call it as what? Cannizzarose reaction. Cannizzarose reaction, it is nothing but a redox reaction in which 2 molecules of an aldehyde do not contain the alpha hydrogen atom can react with a strong alkali and give us to the primary alcohols and the salts of carboxylic acid. You can go with the general reaction. I can go with a specific example directly, SeHO. This is a formaldehyde when it is treated with a very strong base, that is sodium hydroxide. So, what does it forms? It forms an alcohol. So, it forms HCOH plus it forms Na. This is an alcohol. Then it forms HCOO-CO-CO3. Okay, NaCO3 will be formed. Next, you can take a benzaldehyde. When we treat with the base, what will happen? I have taken the 2 molecules of benzaldehyde. It forms a benzyl alcohol and a formation of sodium benzoate. What is Wolff-Kishner reduction? Give an example. So, reduction of an aldehyde with a ketone, reduction of an aldehyde or a ketone with the respective hydrocarbon in presence of hydrazine, which forms a product which we call it as what? Hydrocarbon. You can see that I have taken the example of ketone here, R-C-double-bond-O-R dash, which we treat with the hydroxylamine. What will happen? This oxygen and hydrogen will be combined to form a water, which we can easily eliminate it and forms a intermediate compound. So this intermediate compounds, which is nothing but hydrazine. Hydrazine, when we treat it with the hydrazine, it forms a hydrazone. You can write it here. This is hydrazine. This is hydrazone, which is upon further treatment with a very strong base, it forms an hydrocarbon with the evolution of nitrogen gas. So it will be nitrogen will get combines to form a nitrogen gas. So this bond will break and forms what? Hydrocarbon. Okay. Similarly, you can take the example of formaldehyde, react with the hydrazine, which involves elimination of water and forms a hydrazone, which is upon treated with the very strong base. The very strong base can break this bond and evolve the nitrogen and give rise to the methane, which is an hydrocarbon. So these are all the important questions which has been repeatedly asked from the aldehyde ketones and carboxylic acid. Hope you all understood with this unit. I'll come back with the one more unit. Till that, take care and be safe. Thank you.